Welcome all of you to a new session on Essentials of Symbolic Logic. Here we are discussing symbolic logic and its basics. A search for the definition of logic will lead to hundreds of distinct but closely related definitions. They are all centered around classifying arguments by which the good ones are differentiated from the bad ones. Thus, logic is the study of methods and principles used to distinguish correct reasoning from incorrect reasoning. All our language and thinking is symbolic. We do not speak things but words which represent or stand for things. In other words, the whole fabric of our speech and thought consists of symbols. But when we speak of symbolic logic, we mean the kind of logic which has developed in recent past in connection with mathematical thinking and research. A comparative study of traditional logic will help to understand the former. 1. Symbolic logic and classical logic. Symbolic logic has a short history than the traditional or classical Aristotelian logic. The difference between them is only that of different stages of development. Classical or traditional logic is related to symbolic logic, which is the modern form of logic developed in the last 100 years. It was founded around the middle of the 19th century and carried on to the present mostly by mathematicians. Older logic is purely formal in its approach. It is generally said that in modern symbolic logic, a development of concepts and techniques that were implicit the works of Aristotle is done. Aristotle has introduced into logic the important notion of a variable. A variable is a symbol which can stand of any one of a given range of values. Thus, if x raised to 2 is equal to 4 and x is variable which ranges over real numbers, then the equation is true for the two values of the variable plus 2 or minus 2. But the use of variables in symbolic logic is much wider than this. The traditional classification of propositions into A, E, I and O are on the basis of the propositions. Arguments presented in English or any other natural language are often difficult to appraise because of the vague and equivocal nature of words used, the ambiguity of their construction, the misleading idioms they may contain. To avoid those peripheral difficulties, it is convenient to set up an artificial symbolic language free from such defects in which statements and arguments can be formulated. Symbolic logic has developed in recent past in connection with mathematical thinking and research. The symbolic logic having a mathematical appearance involving heavy use of specialized technical symbols and minimum use of language is the development and refinement of Aristotelian logic or classical logic. The Aristotelian logic contains germs of development in the manner and direction given to it by modern logicians. Classical logic and symbolic logic are interconnected. According to Bason and O'Connor, modern symbolic logic is a development of the concepts and techniques which were implicit in the work of Aristotle. It is now generally agreed by logicians that modern symbolic logic is a development of concepts and techniques which were implicit in the work of Aristotle. The first important name in the development of modern symbolic logic is that of Leibniz. Lifespan is 1646 to 1716. He suggested first the establishment of a universal scientific language in which all scientific concepts could be represented by a combination of basic ideograms. He also suggested that a universal calculus of reasoning could be devised which would provide an automatic method of solution for all problems which could be expressed in the universal language. The next important name in the development of symbolic logic is that of George Boole. Lifespan is 1815 to 1864. His contribution consisted in the formulation of a system of algebra which was first set out in the book The Mathematical Analysis of Logic. Boole applied his algebra to several branches of logic including the syllogism of the classical logic. Other important 19th century logicians who contributed to the development of symbolic logic included Augustus De Morgan, lifespan 1806 to 1871, W. S. Jevons, lifespan 1835 to 1882, and C. S. Peirce, lifespan 1839 to 1914. A number of mathematicians on the continent of Europe were interested themselves in the foundations of mathematics. Their works, in particular that of Gottlob Frege and Giuseppe Pino, was continued by Bertrand Russell. In 1910, in collaboration with A. N. Whitehead, Russell published Principia Mathematica, a monumental work in which a system of symbolic logic is elaborated and made to serve as the foundation of the whole of mathematics. Thus, the chief differences between traditional and symbolic logic are: traditional logic is concerned more with the relation of subject-predicate terms of propositions. Symbolic logic is more concerned with propositions as a unit and propositional relations. Traditional logic is concerned with both form and matter of thought, whereas symbolic logic is purely formal in nature. Even though traditional logic uses certain special symbols, there is an extensive use of symbols in symbolic logic. According to C. A. Lewis, symbolic logic has the following three characteristics. 1. The use of ideograms or signs which stand directly for concepts instead of phonograms which stand only indirectly for concepts. For example, the multiplication sign x is an ideogram, but the written words multiplication are a phonogram. Second, the deductive method, and the third, the use of variables having a definite range of significance. Now, these three characteristics of symbolic logic are the characteristics of mathematics. Thus, the development of symbolic logic has been bound up with the development of mathematics. Now, let us see the advantages of symbolic logic. The modern symbolic logic has a special technique language of its own. It thus becomes a powerful tool for analysis and deduction. The special symbols give us more clarity and thus avoid the ambiguities connected with the use of ordinary language. The special symbols helps us to exhibit clearly the structure of propositions and arguments. It thus helps us to accomplish some tasks without having to think so much. The chief advantages are: 1. It is useful for studies in the foundations of mathematics. Second, it provides a method of testing the validity of arguments of ordinary language. And the third, it offers specific methods of testing the validity of arguments which cannot be done by the traditional logic. Fourth, it provides a procedure for analyzing the structure of propositions. Fifth, it helps in increasing one's proficiency in reasoning. Sixth, it is wider in scope and is applied not only to mathematics, but also other fields like physics, biology, psychology, law and morals, economics, metaphysics, history of logic and theology. 8. Its expressions are more clear in symbolic logic. 9. It makes problem solving more effortless and mechanical. The use of intellect is drastically reduced through symbolization. 10. It drastically reduces the space, time and energy needed for the solution. Logical form and uses of symbols. Understanding the logical structure or logical form of a statement will help us to infer about the nature of the statement and also to know about its relations with other statements without getting into its contents or meaning. Thus, the two statements A, it will rain today or it will not, and the B, Nancy is a student or she is not, are statements having the same structure but different in their content. However, the one who studied logic knows that in spite of their differences in content, both the statements are always true or tautology by virtue of their structure. As the logical form of a statement indicates the type of statement, The logical form of an argument is an indicator of its validity. If any given argument is valid, arguments having the same form or structure of the given argument are also valid. The same goes for invalidity too. Hence, to show that any given argument is invalid, we need to show only that an argument having the same form has true premises and false conclusion. Thus, the argument all fruits are delicious, all apples are delicious, therefore, all apples are fruits is invalid. Even while all its propositions are true, can be shown by constructing an argument having the same form, but with the true premises and false conclusions like all dogs are mammals, all humans are mammals, therefore, all humans are dogs. As we have seen, the logical form plays a crucial role not only in determining the nature of statements, but also in validating arguments. Hence, to bring out the form or structure of the argument is significant in both traditional logic and symbolic logic. The mood and figure and AEIO classifications are examples of this. Symbolic logic takes this process of symbolizing the form of statements and arguments to its extreme by the use of logical syntax. Now, we will see what is logical syntax. Symbolic logic by and large is a language for analyzing arguments. Every language has got syntax of its own. Syntax is the study of signs and symbols. It deals with the construction of language out of signs and symbols. It also deals with the rules governing the uses of symbols and signs. In symbolic logic, syntax mainly deals with two types of symbols, propositional variables and logical constants. A variable is the one which does not have any specific value or meaning. A sign or symbol designates something. Propositional variable is a symbol that designates a proposition. Conventionally, small letters P, Q, R, S are used as propositional variable. The letter P can represent any proposition. In any given argument, if P represents a specific proposition, then P must represent the same proposition throughout that argument. Usually, the first occurring proposition is represented by P, the next by Q and so on. Logical constants are symbols having specific unchanging meaning. They are logical operators. They signify the relation between propositions. They show how the symbol statements are related to form a compound one. The logical operators may be divided into monadic and dyadic operators depending on whether they are related to one or two propositions. Negation is a monadic operator, while conjunction, disjunction, implication and equivalence are dyadic operators. The logical operators conjunction, disjunction, implication, negation and equivalence are symbolized as shown in the screen. Modern classification of propositions. Now, let us see what are propositions. A sentence contains a group of words. For a sentence to be meaningful, the order of the words must be grammatically correct. So, every meaningful sentence must be grammatically correct. For example, killed Ram Ravana is a group of words without any specific sense. On the other hand, Ram killed Ravana is a grammatically correct sentence with a specific sense, and the sentence Ravana is killed by Rama is a grammatically correct sentence and has the same sense as in the second sentence. So, grammatically correct sentences expresses some sense. A proposition is something that may be asserted or denied. Propositions in this way are different from questions, commands and exclamations. Neither questions which can be asked, nor commands which can be given, nor exclamations which can be uttered can possibly asserted or denied. Only prepositions assert that something is or is not the case, and therefore, only they can be true or false. Truth and falsity do not apply to questions, commands or exclamations. Such prepositions refer to some specific sense. So, second and third sentences shown in the screen are one and the same prepositions as they have the same meaning, but they are different sentences since they have different grammatical structure. The sense referred by a preposition may either be true or false depending on what the case is. Thus, the preposition Ram killed Ravana refers to a true sense if and only if it is the case that Ram killed Ravana. The sense referred by a preposition may either be true or false. A preposition is said to be true if its sense corresponds to reality or else it is false. Every preposition must either be true or false depending on whether it has a true sense or not. A true preposition is said to have the truth value true, and a false preposition is said to have the truth value false. Every preposition has a truth value either true or false, and no preposition can assume a truth value between true and false. In logic, the word statement is synonymously used with the preposition. Hence, a preposition may be defined as a statement or declarative sentence which is either true or false. Classification of prepositions. As we have seen, prepositions express a specific sense and are either true or false. Such prepositions that expresses simple sense can be combined to form complex prepositions whose truth values are constituted by their component prepositions. Prepositions are broadly classified as elementary prepositions and non-elementary prepositions. While the elementary prepositions consist of prepositions having specific subjects, non-elementary prepositions are general prepositions. Example for non-elementary preposition is some mammals have wings. Elementary prepositions are firstly classified as simple and compound prepositions. While a simple preposition is the one that contains no constituent prepositions, the compound preposition is composed of two or more simple prepositions. For example, leaves are green, flowers are red. Leaves are green and flowers are red. While fourth sentence and fifth sentence are simple prepositions, sixth sentence is the conjunction of the two and is a compound preposition. The simple preposition is further classified into subjectless prepositions, subject to predicate prepositions, class membership prepositions and relational prepositions. Exclamatory utterances like fire is subjectless or impersonal but with a specific meaning. Statements like it rains are also considered as subjectless prepositions. The subject predicate prepositions are used to ascribe some quality or predicate to its subject. For example, this paper is white. Class membership prepositions are those which speaks about the inclusion of its subject in a class. For example, Socrates is a philosopher, states about the inclusion of its subject, Socrates in the class of philosophers. A preposition which asserts a relation between two or more constituents of it is called a relational preposition. There are various words that express relations. Example, transitive verbs that are drink, love, envy, hurt, etc. These kinds of words expressing equalities and inequalities in any respect, greater than, smaller than, matches and so on. The relational prepositions must be distinguished from prepositions that are not relational. Relational prepositions are based on the number of terms they contain. Those containing 2, 3 or 4 terms are called dyadic, triadic and tetradic respectively. Indira Gandhi is the mother of Rajiv Gandhi. Alice is taller than Joy's sister Betty. Ram's brother Lakshman is the friend of Raju's neighbor Lal. Respectively are examples of dyadic, triadic and tetradic relations. Relational propositions containing more number of terms are called polyadic in general. Compound propositions. There are two main divisions of compound propositions: conjunctive propositions and composite propositions. The simplest of all logical conjunctions is and. By means of and, we combine one proposition with another. Thus, P and Q is a compound proposition constructed out of the two simple propositions P and Q. For example, the two propositions rose is red and violets are blue can be joined to form the conjunctive proposition rose is red and violets are blue. Other than using and, prepositions can be combined using if, then, either or, etc. Such prepositions are called composite prepositions. These different modes of combination are important and have received distinctive names. Accordingly, composite prepositions are classified into implicative or hypothetical, alternative and disjunctive prepositions. Prepositions of the type if P then Q are known as implicative or hypothetical prepositions. For example, if you study well, then you can score high in the examination. The simple preposition that lies between if and then is called the antecedent of the implication, and that after then is known as the consequent. Both alternative and disjunctive prepositions are of the form either P or Q. The difference between them is that while alternative preposition asserts only that either P or Q is the case, the disjunctive one asserts that either P or Q is the case and both cannot be the case. An example can make this clear: either he took medicine or he took rest to get cured is an alternative preposition, since one can take both medicine and rest together. Today is either Sunday or Monday is a disjunctive preposition, since today cannot be both Sunday and Monday together. Hence, the meaning of an alternative preposition is either P or Q, while that of a disjunctive one is either P or Q but not both. This but not both may be explicit or implicit in the preposition. Now, let us see the division of preposition, which is depicted as a diagram as shown in the screen. Prepositions can be largely divided into elementary prepositions and non-elementary prepositions. These elementary prepositions can again divided into two: simple prepositions and compound prepositions. Simple prepositions can be divided into four: subjectless preposition, subject predicate preposition, class membership preposition, relational preposition. This relational preposition again divided into four: dyadic, triadic, tetradic and polyadic. Compound prepositions can be divided into two: conjunctive prepositions and composite prepositions. These composite prepositions can be divided into three: implicative or hypothetical prepositions, alternative prepositions and disjunctive prepositions. Branches of symbolic logic. Symbolic logic chiefly consists of two divisions: one, propositional calculus or propositional logic, and second, predicate calculus or predicate logic. The fundamental difference between the two lies in the analysis of the structure of propositions. Propositional calculus or logic is usually taken as the starting point for the study of symbolic logic. In the branch of logic, we take propositions as the basic unit, but it does not break down and analyzes the internal structure of the propositions. This branch of symbolic logic deals with the validity of arguments containing simple statements and truth functional compound statements. In propositional logic, the form of arguments are represented using statement variables and logical constants. Simple statements are represented using statement variables and compound statements are represented using statement variables and logical constants. Here, every simple propositions including component propositions form the fundamental unit and no further analysis of simple propositions are taken up. The predicate calculus or logic is based on the propositional calculus and uses its methods, but it goes beyond it. It gives some idea of the internal structure of the propositions. For example, Socrates is mortal is symbolized with a single letter in such as P or Q in propositional logic, but in predicate logic it is symbolized as MS, where M stands for the predicate mortal and S for Socrates. In predicate logic, arguments containing singular and general propositions are validated. General statements are represented using predicate symbols, individual constants and quantifiers, and logical constants wherever necessary. In predicate logic, the inner logical structure of statements are taken into consideration in representing the form of arguments. However, predicate logic cannot adequately deal with certain terms like possibility, necessity, etc. Such terms can be occupied in what we call modal logic. Modal logic is again of two kinds, epistemic and deoptic. Epistemic logic is logic of knowledge and belief, while deontic logic deals with a certain kind of reasoning in ethics. Let us now summarize the whole session. Symbolic logic differs from traditional logic in terms of its extensive use of symbols. Their difference is not that kind of, but that kind of, Symbolic logic differs from traditional logic in terms of its extensive use of symbols. Their difference is not that of kind, but that of degree. The use of symbolic logic takes it closer to mathematics and is more accurate, clear and short in expression than traditional logic. The ambiguities in language is overcome in the symbolic expression of propositions. The syntax of symbolic logic consists of propositional variables and logical constants. In modern classification, propositions are divided into elementary and non-elementary or general propositions. The elementary propositions are further divided into simple and compound propositions, while simple propositions are either subjectless, subject predicate, class membership or relational. Compound propositions are either implicative or hypothetical, alternative or disjunctive. The two major branches of symbolic logic are propositional logic and predicative logic. While propositional logic treats simple propositions as its fundamental unit, predicate logic analyzes the internal structure of these simple propositions too. Some limitations of predicate logic is overcome in modal logic. Now, we are giving some assignments for your further studies. 1. Bring out the relationship and differences between classical logic and symbolic logic. 2. Trace the transition from classical logic to symbolic logic both historically and conceptually. Third one, explain the syntax of symbolic logic. Fourth one, illustrate the modern classification of propositions using suitable examples. Fifth one, bring out the difference between propositional logic and predicate logic with the suitable examples. Symbolic logic, Irving M. Copy, 5th edition, Dorling Kindersley Publishers, 2006. Introduction to Logic, 11th edition, Irving M. Copy, Prentice Hall of India, 2005. An Introduction to Symbolic Logic, 3rd edition, Susan K. Langer, Dover Publications, 1967. Logic, a very short introduction. Graham Priest, Oxford University Press, 2000. Thank you for watching this program. We will see in the next session with a new topic. Bye.